Now, the proposed mechanism connecting all these various components is an AI-powered PQC security layer. And this is where things get really cool. I mean, it's one thing to utilize quantum-resistant cryptography, but when you integrate artificial intelligence into the mix, that introduces a totally different dynamic. From a technical standpoint, fusing AI with cryptography theoretically allows the system to actively monitor for threats. So instead of sitting there with a static defense, the AI can detect network anomalies in real time. It can rapidly rotate security keys the very second it flags suspicious quantum-level activity. Univex is gradually integrating this intelligent, dynamic defense mechanism across every single corner of the network we just talked about. Let's zoom in a bit on the highly technical backbone of this operation. To build a quantum-resistant environment, a network absolutely requires rigorous, heavily vetted tools. You can't just wing it. Univex's research focuses squarely on NIST-standardized MLDSA. You might actually know this advanced digital signature tech by its former, and honestly, much cooler name, crystals dilithium. I know, right? It sounds exactly like the fictional fuel they used to power the Starship Enterprise. But I assure you, it is a very real, highly complex algorithm. By utilizing these specific standards, the project establishes its authority, aiming to align with globally vetted cryptography recognized by the National Institute of Standards and Technology. Now, what's really interesting about this slide is how it highlights a classic cybersecurity trade-off: speed versus maximum security. Univex actually proposes using two distinct quantum-resistant algorithms to balance this out. On one side, we have MLDSA 65, also known as dilithium 3. This algorithm requires less processing power, making it absolutely ideal for everyday tasks and rapid transactions where performance is key. But on the other side, we have the heavier, much more robust MLDSA 87, or dilithium 5. This one is strictly reserved for tasks requiring the absolute highest level of security. It's for when you want to guarantee maximum protection against quantum attacks, even if it takes a tiny fraction of a second longer to process. All right, zooming back out to the macro level, the overarching roadmap detailed in our sources boils down to a very clear three-step progression. Step 1 is the foundational integration of AI with post-quantum cryptography. Step 2 leverages that intelligent infrastructure to lock down and secure Web3 components, so your digital identities, sensitive data, transactions, and assets. And Step 3 is the ultimate objective here: preparing Web3 for the post-quantum era at a massive scale. If executed successfully, the stated goal is to give users a seamless, next-generation Web3 environment where all this advanced cryptography and intelligent security operates completely in the background. Which brings us to our final and perhaps most important consideration for today. Are you prepared for the quantum age of cybersecurity? The future of digital security is evolving so rapidly, and the impending threats of tomorrow absolutely require the technologies of today. Now, whether this specific ecosystem becomes the definitive industry standard, well, that remains to be seen. But our dive into Univex Network's blueprint makes one thing abundantly clear: the transition to post-quantum security is no longer just some theoretical concept, it is actively being built right now. I really hope this breakdown gave you a clear structural understanding of how these emerging technologies operate. Thanks so much for joining me to unpack this incredible topic.